Hello, welcome again. We are solving engineering thermodynamics. The topic is entropy. Question number 13 and 14 is an iron block of unknown mass at 85 degrees Celsius is dropped into an insulated tank that contains zero point 0.1 meter cube of water at 20 degrees Celsius. At the same time, a paddle wheel driven by a 200-watt motor is activated to stir the water. Thermal equilibrium is established after 20 minutes when the final temperature is 24 degrees Celsius. CPW is given as 4.18 kilojoule per kilogram per degree Kelvin and Cp iron is given as 0.545 kilojoule per kilogram per degree Kelvin. So we have to find out the question number 13 is mass of iron is option A 25.12 kg, option B 52.167 kg, option C 56.15 kg, option D 75.12 kg. Question number 14 is entropy generated during the process. Option A 1.92 kilojoule per degree Kelvin, option B 1.282 kilojoule per degree Kelvin, option C 3.125 kilojoule per degree Kelvin, option D 2.125 kilojoule per degree Kelvin. So let M be the mass of the iron block and initial temperature of the iron block is 85 degrees Celsius, that is given. Okay, and it is dropped into water of having temperature 20 degrees Celsius. So temperature of initial temperature of water is 20 degrees Celsius, and the final temperature of both iron and water is 24 degrees Celsius. Okay, so as work is supplied by the wheel at a rate of 200 joule per second or 200 watts, and it is supplied for 20 minutes so that the temperature of both the water and iron block become equal. So work supplied by the paddle wheel will be converted into heat. Okay, and as volume of water in the tank is zero point 0.1 meter cube, so mass of water in the tank will be your 0.1 to 100 or 1000 or 100 kg. Okay, so specific heat of water is this 4.18 kilojoule per kilogram per degree Kelvin, and Cp of iron is 0.45 kilojoule per kilogram per degree Kelvin. So work converted into heat by paddle wheel and heat by iron block. Okay, heat by paddle wheel and heat by heat has come from both from the iron block as well as by the work done by the paddle wheel. Okay, and that heat is gained by water. So heat gained by these two substances will be equal to heat gained by water. So for 20 minutes, as the work has been done for 20 minutes, so and the paddle wheel will supply this much of work, 200 into 20 into 60, or this much of heat for 20 minutes. Okay, and mass of iron block is m, and specific it is 0.45 into 1000, and the temperature difference is 85 minus 24. Initial temperature is 85 or 358 and final temperature is 24. Okay, and this is the m is gross. We have assumed that mass of iron block is m. Okay, now the mass of water is this quantity 0.1000, and Cp in terms of joule is 4.18 into 1000. Okay, and the temperature increase of water is 24 minus 20. Okay, so from this we can find out mass. Solving this out, we get 52.167 kg. So just by energy balance, work supplied by the paddle wheel, heat supplied by the iron block will increase the temperature of water, or okay, we can get mass of iron block. Okay, now second question is entropy generated during the process. So entropy change will be decrease in entropy of iron block because iron block is supplying heat, and increase in entropy of water. uh, Paddle wheel will not, there will be no change in entropy of paddle wheel because it is supplying work. Okay, but this but the work supplied by the paddle wheel uh, uh, generates heat. So we will take this into account. So the total heat gained by water will be this. Okay, either it is either from iron block, and or from paddle wheel. But there will be no entropy change of paddle wheel. Okay, because it is supplying work not the heat, and this work is converting into heat. So total heat supplied to the water is this. Okay, so the as the final temperature of iron block is Tf, initial temperature is T iron, so entropy change of iron block is mCp iron ln Tf by T iron, and entropy of increase entropy of water is mCp W, final temperature water by initial temperature water. So putting the value m we have found out that is 52.167. Okay, and Cp of iron is 0.45, and if you only multiply by 1000, and final temperature is 24 or 297, initial temperature is 358. Again here the putting value, mass is 0.1 and C value is 4.18, and this is so from this we get entropy as 12482 joule per degree Kelvin, or 1.282 kilojoule per degree Kelvin. So answer is option B.